Modulus of x squared minus 4 is greater than or equal to the modulus of x minus 3. Let's have a go at sketching this on an axis then. Now, what have we got here? The modulus of x minus 3, it flips at 3, doesn't it? After 3 is equal to the value itself, which is x minus 3. So we can draw that in that line. Gradient 1 intercept minus 3. Part line is here from 3 onwards. X equals 3 onwards. And then we've got the other part of the line on this side, which is when x is less than 3 and we flip a minus through this, we get 3 minus x. So that's intercept 3 gradient minus 1, which also comes up from here through the intercept value at 3, doesn't it? Like so. This value is 3 as we said. And we can label the line here as 3 minus x, and this line, part line, is x minus 3. Okay, that's that one done. Now we need to draw the quadratic with a modulus around it. So let's just draw the quadratic first. So first of all then, it's going to have roots when x is 2 and minus 2, isn't it? Because that's when this equals 0. So mark off 2 and minus 2. Now when x is 0 we get 4. But if I'm drawing the quadratic, it would be down here at minus 4, wouldn't it? So it's going to be a quadratic, it's going to come down. I'm just drawing the quadratic at the moment. Go through minus 4, come back up, and go like so. It's supposed to be symmetric both sides, but it's the modulus. So these negative values need to be flipped up to being a positive. It goes through 4, so it's going to go above here, above the line, and then it's going to come back down and go below, I think. I think that's how it looks. So we can get rid of the stuff underneath the axes now that we used to draw the sketch, and hopefully I can do a bit of that, get rid of the worst of it, like so, and here, that'll do. Okay, so that's what we've got then. So we need to find out when these 2 points happen here and here, so let's put them in another colour. Oops, put them in another colour then. So it's this point, and also here, isn't it, this point here. Now that would be when this quadratic is bigger than, but it's also bigger than here. So there's another point here, and it's also bigger than, the quadratic goes above, probably over here somewhere, doesn't it? So we've got to solve 2 solutions. We've got 2 solutions here to solve, and 2 solutions the other side to solve. So let's have a go at that then. So we'll call this one A1 and this one A2, and the inner 2 we'll call B1 and B2. So as far as A1, A2 is concerned then, when does this line, which is the line 3 minus x, equal this quadratic, which is the outside part of it, isn't it, which is the actual quadratic itself, x squared minus 4. So when does that happen? Well, let's move everything over to the right hand side. X squared plus x, and then minus 3 minus 4 is minus 7 equals 0. Let's get the roots. Minus b is minus 1, plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times c, which is minus 7, so that changes that to a plus, all over 2 lots of a, and a is 1. So we get minus 1 plus or minus the square root of 28 plus 1 is 29. So we've got our values. So a1 would be the smaller one of the two, so that would equal minus 1 minus root 29 all over 2, and a2 would be the bigger one of the two, and that would be minus 1 plus the square root of 29. Whoops, just need a bit more room there. So a2, I'll put it here, is equal to minus 1 plus the square root of 29 all over 2. So that's a1, a2. Now we need the other one. We need b1 and b2. And that comes from solving the inside problem, the two intersections here, and that would be when this inverted curve, which is the minus of this, 4 minus x squared then, is equal to, and this line here is still 3 minus x, isn't it? So move the x squared over, we get x squared, and then leave the x where it is, minus x. Move the 4 to be minus 4. 3 minus 4 is minus 1, equals 0. So x equals then minus b, which is 1, because it's minus minus 1, plus or minus the square root of b squared, 1 squared, minus 4 times a, 4 times 1, times c, which is minus 1, all over 2a. So it's equal to 1 plus or minus the square root of 4 times 1 times 1. It's 4 plus 1 is 5 over 2. So b1 then is equal to, b1 would be the smaller one of the two. So it'd be 1 minus root 5 over 2. And you can see b1 is negative, which this is. And b2 then is equal to 1 plus root 5. And it's positive in the diagram, so we're okay there. Our sketch looks fine. 1 plus root 5 over 2. So, those were the four values then. So when is the modulus of the quadratic bigger than this? Well, it will be bigger between b1 and b2. So here, x can go up 2. Can it touch b2? Can it touch b2? Yes, it can, because it's greater than or equal to, so it can touch b2. 1 plus root 5 over 2. And it can touch, and it can go down to and touch 1 minus root 5 over 2. So there's the first solution set then. Now the other solution set is when after a2, wasn't it? And before a1. So after a2, or x is bigger than or equal, because it can touch a2, which was the bigger one of these, minus 1 plus square root 29 over 2, or x can be smaller than the other a1, the a1 value, minus 1 minus root 29 over 2. So there's our solution set.